This video considers the question, what is heat? And I'll start by admitting that if people weren't aware, physicists tend to be a little bit geeky. And what I mean by that is that we're a little bit obsessive, almost OCD about words. We like to try and get the words correct as much as possible. If we have a sentence in physics that makes sense to us, if you change a single word, and as far as anybody else is concerned, well, it basically means the same thing, to a physicist it's highly likely not to. When a physicist makes a statement, there's usually some part of that statement that's like a get-out clause, just in case we might be wrong. We don't want to say something that's incorrect, but we do want to give an impression of what we understand the situation to be. Let me give you an example. As far as I'm aware, based on past experience, I think the sun will rise tomorrow. Okay, well, I'm going to ignore the tautology there and admit the fact that I don't actually know that the sun will rise tomorrow. But it seems to have done so for as long as I've been aware, and it's never missed a day. So I'm judging that it will rise tomorrow. But if the sun did not rise tomorrow, then I could just say that you can't criticize me too much. I did say, as far as I'm aware, and I admit I am not aware of everything. And I also said, I think, and that's not the same as I know, but it's worse than that. I haven't stated everything that I could state. For example, what if I'm close to the north or the south pole of the planet? Then depending on the time of year, you could have perpetual light or darkness, i.e. the sun will never rise or set. For example, in this situation shown here, the Earth's axis is at some angle that's not 90 degrees from the imagined line between the Earth and the Sun. It has a 23.4 degree tilt. In this particular example, you can see that at the North Pole there is constant darkness, and at the South Pole there is constant daylight. So the sun doesn't rise in either of those two locations. What about if I was not on a fixed point on the Earth? If, for some reason, I'm moving as fast as possible, either with or against the rotation of the planet, then this would raise a question of how am I defining the word tomorrow? Okay, I'm not going to lie, I did actually look for an image on the web of somebody or something running towards or outpacing the sun, and I couldn't find one. So I decided to show this picture instead, because my dog, well, what can I say? She's cute. A nice clip that shows this idea, both for clarity and careful consideration of language in a different scenario, is the 1996 movie called Phenomenon. It starred John Travolta, it was written by Gerald DiPeggio, and briefly the movie is about a guy who is well liked but not that bright, and one night he gets struck by a pulse of light that knocks him over. The result is that his intellect is boosted up. The scene I'm about to show you takes place as he is identified as something a little bit special, and he's being tested by Brent Spinner. And you will see the emphasis that I'm trying to make here about language.
All right, I'll start the questions, and I'll be timing your responses, and we'll be recording. Any questions?
What's your first name?
My first name is Bob.
Shoot, Bob.
Right. Name as many mammals as you can in 60 seconds. Ready? Go.
60 seconds. Well, how would you like that? How about alphabetical? Aardvark, baboon, caribou, dolphin, eohippus, fox, gorilla, hyena, ibex, jackal, kangaroo, lion, marmoset, Newfoundland, ocelot, panda, rat, sloth, tiger, unicorn, varmint, whale, yak, zebra. Now, varmint is a stretch, so is Newfoundland. That's a dog breed. Unicorn is mythical, eohippus is prehistoric, but you aren't being very specific now, were you, Bob?
Well, I'll try to be more specific. You ready for the next one?
Shoot.
Answer as quickly as you can. How old is a person born in 1928?
Man or woman?
Why?
Specifics, Bob.
Okay, one more time. How old is a man born in 1928?
Still alive?
If a man is born in 1928 and he's still alive, how old is he?
What month?
If a man was born October 3rd, 1928, and he's still alive, how old is he?
What time?
10 o'clock p.m.
Where?
Anywhere.
Well, let's get specific, Bob. I mean, if the guy's still alive, born in California, October 3rd, 1928, 10 p.m., he's 67 years, 9 months, 22 days, 14 hours, and 12 minutes. If he's born in New York, he's 3 hours older now, isn't he?
How do you do that? How do you make that pencil move? Is that a trick pencil?
No. I ask it to move. I mean, I could say that I will it, but that'd be more like a command. This is more like a collaboration, a partnership.
Partnership.
Mm-hmm.
With a pencil.
Well, why not? We're all made up of the same stuff, aren't we?
Wood?
Energy, Bob.
Okay, so the point I'm making is that we have to be very careful with our language. And I would also note the final comment in that clip. It's all about energy. Okay, getting back on track now. When you listen to physicists, they often talk about forces and energy. Those are the two big ideas that we tend to use. So let's talk about heat. Physicists have argued about what heat means for quite some time. I have personally had a conversation about what the word heat means that's lasted for over an hour, and I have genuinely loved every minute of it. When we talk about what heat means, we need to realize that there are many different forms of energy, with two main types: kinetic energy associated with motion and potential energy associated with the position of an object within something that we call a field. Now this gets a little heavy, so let's just not get into that, particularly if we start talking about things like vibrational energy, which can contain a little piece of kinetic and potential energy. So let's get back to the main question. So what is heat? One of the problems with the word heat is that it's got two definitions. Or more correctly, it's got an old definition and a new definition. And the difference between these two definitions is the cause of some of the problems that people have in understanding what the word heat actually means. Now, the main problem with the word heat is that people think it's a type of energy, like one of the forms that we see in this image. And it is not. Even though irritatingly, this diagram does have the word thermal there. Heat is not a type of energy. Heat is a process. The definition of heat is the amount of energy transferred from one place to another as a result or due to a temperature difference. So first of all, let's just break this sentence down. The amount of energy. So that means that it's going to be measured in the units of energy, joules. It's transferred. Transferred means moved from one place to another. And then importantly, due to a temperature difference. So it's not just the movement of energy, but it's got to be due to a temperature difference. So just before we finish, let's do two quick things. Let's look at an example of what this means, and let's check out the knowledge of the word heat on the web. The idea of what we've got in front of us here is a hot object to the left and a cooler object to the right. The hot object is represented by the colour red, and the cooler object is represented by the colour blue. And they're basically pushed together so that they make good thermal contact. In other words, heat can move, energy can move across from the one to the other because there is a temperature difference. Now, when we see this situation, we always see that energy will flow in both directions, not just from the hot to the cold, but from the cold to the hot. However, the amount of energy moving from the hot object to the cold object is greater than from the cold to the hot. So there is a net transfer of energy from the high temperature object to the low temperature object. The amount of energy moving is what we call heat. Okay, let's have a look at what Google says about heat. Okay, if we look up heat, we get a bunch of hits about a movie called Heat. It's a great movie. If you haven't seen it, watch it. Let's go back and let's type heat physics. Okay, what we got here? Heat, energy that is transferred from one body to another as a result of a difference in temperature. Okay, I'm kind of happy with that. I can't really see enough from Wikipedia there to know because of that ... so I don't know whether I'm happy with heat from Wikipedia. What is the meaning of the word heat in physics? Heat is a form of energy. That is not correct. That can be transferred from one object to another, or even created at the expense of the loss of other forms of energy. Okay, well, I'm kind of okay with that, but I just don't like the beginning because it definitely says it is a form of energy, and that is simply not correct. Okay, I'm looking at specific heat capacity, National 5 Physics Revision from the BBC, and it clearly states there, and I can see that this is bite size. Heat is a form of energy. It is measured in joules. It is not. It is measured in joules. It is not a form of energy. So the conclusion from this is that you need to be really careful about the word heat. It is not always expressed in the best possible way. Please remember, final comment, heat is not a form of energy. It is a process associated with energy. Okay, stay safe and be good.